So, as the number of students are very less, I will be starting in 5 minutes. I'm just waiting that some more people will join, and I will be starting the class. So, I hope my voice is clear and my screen is visible to you.
Yes,
So I will be starting the class now. So, hello everyone. My name is Himanshi Singh. I'm from Department of Mathematics, IIT Jodhpur. Currently, I'm pursuing my PhD from here in a broad area of probability and statistics. So today I will be discussing. So I will be giving you a brief recap about the topics which has been taught in week 5 lectures, and further we will be solving some of the problems related to those concepts. So in a week 5 lectures, first of all, it was so in the previous lectures we have covered some of the discrete distribution, then some special continuous distributions has also been discussed. Now, apart from all those distribution, there is a very important distribution which is very helpful and which is very popular among all the continuous distributions, which is a normal distribution. So this normal distribution is also known as the Gaussian distribution. And it is a distribution where the random variable is varying over the entire real line, that is from minus infinity to infinity. It can take any value, and the density function, that is the probability density function, is given as 1 upon sigma under root 2 pi exponential of minus 1 by 2 x minus mu upon sigma whole square. So this is the form of the density, and here this mu is belonging to the real number. So mu can be anything from minus infinity to infinity, and this sigma is greater than 0, so it is basically positive. Now, for this normal distribution, this expectation of x is mu, variance of x is sigma square, and also this kth order central movement, that is expected value of x minus mu to the power k, will be 0 if k is odd. So the odd ordered central movements for these distribution is 0, and this even ordered central movement, that is expected value of x minus mu to the power 2m, where m is integer, that is m can be 0, 1, 2, 3. So then that is equals to sigma to the power 2m, 2m minus 1, 2m minus 3, and it is going up to 1. So this is the central moment, which is even ordered central moment. Apart from this, this moment generating function for a normal distribution is given as e to the power mu t plus 1 by 2 sigma square t square. So this is basically the properties or the parameters on which the normal distribution depends. It is basically the summary of those things. Now, apart from normal distribution, this there is a property of normal distribution, that is linearity property. So basically, if I have a random variable x which has a normal with mean mu and variance sigma square, and so x is following normal distribution, then if I consider a linear transformation of x, that is ax plus b, where a is non-zero, then this random variable y will be a normal distribution. Sorry, it will be a normal random variable with mean a mu plus b and variance a square sigma square. So this is basically the linearity property of normal distribution. And in particular, if I consider a linear transformation which is x minus mu divided by sigma. So basically, I'm considering here this linear transformation of x, then this is a normal random variable with mean 0 and sigma square to be 1. So this kind of distribution n01, we call it as a standard. So z is a random variable which is following normal 0, 1. Then we say that z is a standard normal random variable, and this is a very important random variable, or we can say this is a very important distribution, which is basically a particular case of normal distribution, and whose density is given as fzz is equals to 1 upon under root 2 pi e to the power minus z square by 2. So this is basically the density of the standard normal distribution. Now, so we have binomial distribution, Poisson distribution, we have already studied. So these sometimes calculation for the binomial distribution, that if you want to calculate the probability x less than is equals to x for a binomial distribution or for a Poisson distribution, then in that case that calculation may be very lengthy sometimes, and so in order to avoid that, we can also have a theorem, or we can say an approximation to the binomial distribution, that is normal approximation to binomial. So we have already studied about the Poisson distribution. We can approximate the binomial by Poisson distribution also, and we can approximate both binomial and Poisson distribution by normal distribution also. So how can we approximate it? So if I have a x as a random variable which is following binomial n p, then if I consider n to be very large, so if the sample, so if the size of the binomial distribution is very large and is tending towards the infinity, then x minus np divided by under root npq. So this is a random variable again, and which is approximately the standard normal random variable. So this is a binomial approximation. So if I want to calculate some probability of x less than equals to x, then I can calculate it by using this normal distribution also. So we will be like tackling this kind of situation in the question. We will be discussing further the application of this thing. So apart from normal approximation to binomial, there is normal approximation to Poisson distribution. So basically, if I have a random variable where it is following the Poisson distribution with rate lambda, then as this rate increases, then we can approximate the distribution of x by a normal distribution, which is basically x minus lambda by root lambda. It will be approximately standard normal random variable. So this is a normal approximation to Poisson distribution. Now, apart
Ma'am,
from this, Yes.
Sorry, this one question. Lambda goes to infinity or time goes to infinity? The interval goes to infinity.
No, no, it is lambda when the rate increases. Because we have only the parameter for this Poisson distribution, we have only one parameter, that is lambda.
Yeah, but here the lambda is also like this is in terms of the unit of the lambda is in the terms of the time interval.
No, lambda is basically number of times. So this lambda is basically rate. So
Yes,
this is
rate.
rate.
Yes. So the unit of lambda is time here, right?
No,
Because uh, what
no, this lambda, the unit of lambda is not time. So if the what lambda is, so if I consider that number of accidents per month.
yeah. So here the unit is
So
time.
this
Per month
so if
is the
I
unit.
so per month is not the unit of lambda. So lambda is basically, if lambda is 2 means there are two on an so there are two accidents per month, we are saying.
Okay.
So this is
So
basically the yeah.
sorry. Because the
So this is
PDF of
basically the
Poisson distribution.
yeah. So PDF of Poisson distribution is what we have, e to the power minus lambda, lambda to the power x upon x factorial.
X X factorial, right? So
Yeah.
as the X increases,
So you are
so
basically saying if x is increasing means what?
because e to the power lambda, it is minus lambda x, na, correct? In
Yeah, yeah, it is minus lambda. E to the power minus lambda, lambda to the power x divided by x factorial.
X factorial, that is the PDF, right? So is,
Yeah.
doesn't our as X goes to infinity, so as our time goes to infinity, our Poisson distribution
So
will follow.
x, what x is? X is what x is counting. X is counting that the number of accidents basically, and lambda is number of accidents per unit time. Now that unit can be like, it can be month, it can be per minute, it can be per hour. So it is like that.
And X is time, correct? Or X is
No,
number
no,
of
x is
accidents.
not time. So x is a random variable which is basically counting the number of accidents.
Okay. Okay.
Okay, so
Okay. Okay.
time is different thing, and number of accidents. It is counting the number of accidents. For example, if I so x is basically a random variable which is counting the number of accidents, but lambda is a rate.
Okay. Okay. Sorry, I think I confused with something else. Sorry.
Yeah, so it is x is not time basically. Okay.
Okay. Fine.
So this will be this if the rate increases. So rate increases means the number of accidents per unit time is increasing basically. Okay. So in that case, we will say that it is approximately normal. Is that fine?
Yes, ma'am.
Okay. So apart from this, we have this log normal distribution. So if I consider y to be normal distribution with the mean mu and variance sigma square, then if I consider this exponential of y, then this will be a log normal distribution. Now the density of this log normal distribution will be of the form 1 upon sigma x root 2 pi exponential of minus 1 by 2 sigma square log x minus mu whole square. And here this x is positive. So uh, if I consider this x to be random variable e to the power y, so y was a normal random variable which was varying from minus infinity to infinity. Now since x is exponential of y, so it will always be positive. So here this x will always be positive. Mu is in R and sigma is greater than 0. So this is called log normal distribution, and the expectation of x for this distribution is e to the power mu plus sigma square by 2. and variance is e to the power 2 mu plus sigma square e to the power sigma square minus 1. So these are basically the expectation and the variance, mean or the variance of the log normal distribution. So this can be calculated using the normal distribution, which have already been discussed by in week 5 lectures only. So this is log normal distribution. Now, apart from this, the discussion of the random variable was like we have discussed the discrete random variable, continuous random variable, and in continuous random variable, today we have discussed the most important is the normal random variable, so normal distribution for a continuous random variable. Now, apart from this, if I have a random variable, then what about if I consider a function of a random variable? Then whether it will be a random variable or not, and if it is a random variable, then how can we find out the PDF of that random variable? So this is a there is a theorem that if x is a random variable, which we've defined on omega pp, so b is a the Borel set, and this p is a probability measure. So if and we are considering that g is a measurable function from R to R, then gx is also a random variable. So if x is a random variable, then in order to gx to be a random variable, g should be measurable. Now, apart from this, if I have a random variable x whose CDF is given fx, then if I want to find out the distribution of gx where g is a measurable function, then we can find out it is determined. So it is determined through the CTF of the random variable x, which we will be focusing in the problems we will be discussing further. So how to find out the PDF of the function of a random variable will be the topic of concern. So apart from this, now if this function of a random variable is a certain kind of function, then we have a formula directly by which we can find out the PDF of the function of random variable. So if I have a continuous random variable whose PDF is fx, and if I consider the function of random variable that is gx, now if this g is differentiable function for all x, and either the derivative of it is greater than 0 or less than 0, means either it is strictly increasing or strictly decreasing function, then in that case this y is equals to gx will again be a continuous random variable, and its PDF will be of the form fx g inverse y, derivative of g inverse the absolute value of derivative of g inverse y, where y is lying between alpha and beta, where alpha is minimum of g minus infinity to g infinity, and beta is minimum sorry, this is minimum and this is maximum here. So this is maximum here. So this is a maximum of g minus infinity to g infinity. So this basically the range of y is dependent upon the range of the x. Through the range of the x, we will find out that the variation of y, that y is varying where to where. Okay, so this is for the strictly increasing or strictly decreasing function. So if the function is like if I have a function which is strictly increasing in this interval and then decreasing, like if I have this 0 and if I have this as 1 by 2 and I have this 1, then in 0 to 1 interval I have an increasing function, and in interval 1 to 2 I have a decreasing function. Then how we can find out? So this theorem is for the strictly increasing and or strictly decreasing function. Now if I have this kind of scenario, then to tackle this kind of scenario there is another theorem. So if I have a continuous random variable and gx is a differentiable function, and here the assumption is the derivative of gx is again continuous and non-zero. Now non-zero, it is non-zero at all but finite number of values. So apart from finite number of values, it is zero. So derivative is continuous and non-zero. So it is non-zero for it is non-zero for all but finite number of values of x. Then for every real number y, there will exist a positive integer ny, and real inverses x1y, x2y, xny, such that the g of xky is y. So basically xk is g inverse y, and the derivative of xky is non-zero for these case. Or if such condition does not happen, then we will say that ny is 0 for that case. Then y will be a continuous random variable whose PDF will be summation k is equals to 1 to n fx g inverse y, absolute value of g dash xky whole inverse if n is greater than 0, and if n is 0 then it is 0. So basically what this theorem is saying, so if I have a if I have a function of random variable, now if it is like this, it is like this x square, for example. Now this x square is basically, it is decreasing from infinity, minus infinity to 0. This function is basically decreasing, and from 0 to infinity this function is increasing. So here we can split the interval minus infinity to infinity into two intervals, minus infinity to 0, comma 0 to infinity, and here the function is strictly decreasing, and here the function is strictly increasing. So for both the intervals, what we will do, we are basically applying this theorem for both the intervals separately, and we are just adding them. So basically this is the concept of this theorem. So we'll apply the previous theorem for this case, for this interval, for this domain, and apply the first theorem again for this interval, and we will basically add those both of the probabilities or the densities to get the density of y for the whole domain minus infinity to infinity. So this is basically the idea for this theorem. So x1, x2, xn, this n should be finite, because so such kind of situation, this is happening for the finite number of times. Then we can obviously we can do the summation for the finite number of times, that is n. So we will be using this theorem also in order to tackle this kind of situation. So this is basically, these are the theorems and the normal distribution we have discussed. These all things are discussed in the week 5 lectures. So if someone has any doubt in this concept or something, then you can discuss it with me. Otherwise, I will be continuing with the problems. So so should I continue with the problems? So there is no doubt. Just confirm first. Okay, so I will be like moving forward towards the first problem for the for today's session. So we have this problem number one, that is x is a uniform random variable on interval 0, 1. So I have x. So this is following the uniform distribution in interval 0, 1. So basically the density will be of the form fxx is equals to, so it will be 1 if x is between 0 and 1, and it will be 0 elsewhere. So I have a function of a random variable x, that is y, which is y is equals to minus a. So it is capital X here. So it is minus a log x, and here a is positive. So y is a random variable or not? So in order to in order that y is a random variable, what we should have, that this y, which is basically, this is gx. Okay, so this g should be measurable. So here we have this log function, and this log function is a continuous function, so it will be measurable function. So since log is a continuous function, so this will imply that y is a y is a random variable. Okay, so apart from this, if y is a random variable, then what is a PDF for y? So what is a PDF? In order to find out the PDF, so what we will do, we need to find out. So y is minus a log x, and here what we have, that x is between 0 and 1. So yeah, So if this is a minus a log, so first of all, let us check that whether it is an increasing function or decreasing function, or what kind of function is it. So if I consider this to be gx, now g dash x will be minus a by x, so which is less than 0. Because x is between 0 and 1, so it will always be less than 0 since a is greater than 0. So it is strictly decreasing function. Okay, now it is a decreasing function, and we will find out that what is the, so we can apply the theorem which we have discussed. So now let us find out the inverse first of all. So the inverse is what? So minus a log x is equals to y. So log x is equals to minus y by a. So x is equals to e to the power minus y by a. So this is basically what? G inverse of y. Okay, so this is G inverse of y. So we need to find out that what is the so what is the density of, so let us consider density of y to be h. So hyy is equals to, by the theorem directly, what we can say that it is fx of G inverse y into the modulus value of d G inverse y over dy. So the density of G inverse, so the density of x is what? So this is 1 when x lies between 0 and 1. So this will be, this quantity will be 1 if G inverse y is between 0 and 1. And what is the derivative of this quantity? So this is minus. So what is the derivative of G inverse y? Okay, we have not found it. So it is derivative of e to the power minus y by a divided by dy modulus value. So it will be, so if I find out the derivative of this thing, so it will be minus 1 by a modulus of e to the power minus y by a, when 0 is less than is equals to G inverse y, it is e to the power minus y by a equals to 1. So h y is equals to e to the power 1 upon a e to the power minus y by a. Now let us consider this thing, that e to the power minus y by a. So what is this? That 0 is greater than equals to e to the power minus y by a. So this condition will hold, this left hand condition will hold for every y, because this is the exponential term, so it will always be positive. What about the second one? E to the power minus y by a less than or equals to 1 means minus y by a less than or equals to 0. We are just applying the log, and minus y is less than is equals to 0. 0, because a is positive, so we can multiply or we can send it there, and y is greater than 0. So basically what this condition is showing, that y should be greater than 0, and for this condition y can be anything. So basically in the intersection what we have, y should be greater than 0. So our density will be hyy is equals to 1 upon a e to the power minus y by a. So y should be greater than 0 for that, and it will be 0 elsewhere. So this is important to find out, but the range, that in the range of the random variable y, what the range of the random variable y is, this is what also very important in order to find out the density. So this will be the density. Now apart from this, what we need to find? We need to find the expectation of y. So expectation of y will be what? So it will be integral of y hyy dy, and it will be from 0 to infinity. So we can also see directly from here that it is nothing but this is a exponential distribution which we have already studied, and here the rate is a. So basically this is a, so this y is basically a exponential random variable with rate a. Okay, so expectation there, what was the expectation of y? So it was expectation of y was, so the expectation of y was a. Okay, so directly from the exponential distribution we can write it, or you can also solve this expression, and you will get that expectation of y is a. Okay, is there any doubt in this? So is this thing is clear? This is an exponential distribution, and all the things are clear for this question. How we find out the range of the random variable y, and how we have find out the density of random variable y. So is it clear? Just at least respond.
Yes, ma'am.
So if anyone has any doubt, then you can discuss it, or I will be, or otherwise I will be moving forward. So, okay. So this is question number 2, which is as so it is x be a random variable having a following probability density function, which is lambda e to the power minus lambda x, so which is basically the exponential distribution. So it is exponential distribution, and exponential 1 by lambda. Okay. So here where lambda is greater than 0. Now suppose gx is a function, so g be a function where gx is a greatest integer x, so it is basically the floor function. So where the floor function is basically the integer less than or equals to x. So basically, if I have 5.9 floor 5.9, so it will be nothing but 5. So this is the definition of function. So this is g of 5.9. Okay. So then gx is which kind of random variable? So whether gx is a continuous random variable, discrete, or mixture kind of random variable. Just any one of you can let me know if. So gx is nothing but uh, greatest integer function. So, so what kind of random variable is it? So how, so the kind of values, so what kind of values it will be taking in its range? X can be greater than 0. So x can be anything, 0, 1, 2, 3. It can be integer, it can be rational, it can be anything. X can be a positive real number. Now what is this greatest integer x? What kind of values it will be taking? Anyone?
Integers.
So it will be integers. So it can be 1, 2, 3, 4, these kind of things. So it can be 1, 2, 3. So it is taking integral values basically. So it will always be positive because x is positive. So we can say that it is having positive integral values. So they are belonging to z plus, we can say. Okay, so since it is taking countable number of values, so we can say that this is a discrete random variable. Okay, because it is taking countable number of values, and in the definition of discrete random variable, we are having that if x is a random variable which is taking a countable number, it can be finite or countably infinite. So if they are countable, then we will say that the random variable is a discrete random variable. So basically, gx is a discrete random variable. Now, what will be the density of gx basically? So if I consider, so because gx is a discrete random variable, so obviously the density I'm basically, density means the PMF, we are talking about the probability mass function. So probability gx is equals to k, we can say. So gx is what? Probability. This function is equals to k. Okay, so k is obviously, k belongs to the positive integer. Now, what is the probability that this, so what kind of events we will have here? Now, what kind of x we will be having so that the greatest integer x will give us k? So if I have this k here and this k plus 1 here, okay, now if x is a, so x, if x is less than k, like if I have x is, so for example, in order to explain it, let k to be 3, for example. Okay, so probability that the greatest integer x is equals to 3. So what kind of x we can have? So x can be, so x can be, so what kind of x we can have for this? 3.1, 3.2, 3.3, 3.9, 3 also. So any number between 3 and a number which is less than 4 we can have here, because if I consider this to be 3.9, then it is giving me the greatest integer which is less than or equals to this, so what is the definition here? So this is the greatest integer which is less than or equal to x. So we have x here 3.9. So greatest integer which is less than is equals to 3.9. So the integer which is less than is equals to 3.9 is basically 3 only. The greatest integers which is having this kind of situation. So all these will have this, the greatest integer to be 3. So all the members, so for this scenario, so this can be the probability that x is between, this can be greater than equals to 3 and less than 4. So for all the values of such x, we will have this probability greatest integer x to be equal to 3. So in this scenario, what we can consider, that probability of this x is equals to k. This is equals to nothing but probability k less than is equals to x, and which is less than k plus 1. So is it fine? Is it okay? So if x is any number between k and k plus 1, strictly less than k plus 1, then greatest integer will give us the value k for that.
Yes, ma'am.
Okay, now what, so from here we can calculate, because x is nothing but a random variable whose PDF is the exponential density. So we can calculate it from here. So what we need to find out? We need to find out the PMF of this. So we need to find out this to be equal to, so this will be nothing but integral from k to k plus 1, and what is the density here? Lambda e to the power minus lambda x. So lambda e to the power minus lambda x. So just calculate this and just let me know what is the density. So just find out the integral, put the values of the upper integral and lower upper value and the lower value, and just let me know what this PMF is coming. So this is probability. If I want to integrate it, then lambda, so e to the power lambda x will be minus e to the power minus lambda x divided by lambda and k2 k plus 1. So this lambda and lambda will get cancelled, and minus we can take outside. So this will be e to the power minus k plus 1 into lambda minus e to the power minus k lambda. So lambda, x in place of x we will put k because we are integrating it with respect to x. So it will be e to the power minus k lambda minus e to the power minus k plus 1 lambda. We can take out common and all the things we can do. So it will be say e to the power minus lambda k 1 minus e to the power minus lambda. Okay. So this is the basically the PMF for this. Okay. Now what is it asking, that what is the expected value of gx? So expected value of gx, if I want to find out the expected value of gx, so gx is basically that function which we have considered. So it is nothing but, so we know that these values are running from 1 to infinity. So because gx can take values uh, from 0 to infinity in fact, because x can be greater than, so if this x is greater than 0, so it can be 0.5 also. Now if the value is 0.5, then what will be this greatest integer 0.5? It will be 0. Okay, so the value is varying. So this is very important, that from where the values are varying. So gx is varying from, basically here I should mention that gx is varying from 0, it can be 0 also. So 0 to 1 to 3. So now expected value, in order to find out the expected value, because it is a discrete kind of random variable, so there will be summation x, or we can say, let us consider this to be y. Okay, so y is equals to 0 to infinity. Okay, and here we will have y. So y is basically gx, and what is the density of this? So what is the PMF of this? Probability e to the power minus lambda y and 1 minus e to the power lambda. Okay, so here from this, what we can say, we can take this 1 minus e to the power minus lambda to be outside, and this is summation y going from 0 to infinity, y e to the power, oh sorry, y e to the power minus lambda y. Okay, so this the sum of this series is e to the power minus lambda y. So it is e to the power, this is, this is e to the power minus lambda term we have taken outside, so it is minus lambda. So it is nothing but e to the power minus lambda divided by 1 minus e to the power minus lambda whole square. So it can, we can solve it like we what we can do, we can just find out this c. So what we can do in order to find out the summation. So this is y is equals to 0 to infinity y e to the power minus lambda y. Now if I, in place of this, if I consider this series e to the power minus lambda y, where y is going from 0 to infinity. So this is basically the geometric series, and we have a expression for this. So that is 1 upon 1 minus e to the power minus lambda here. Okay, now what we will do, now this thing, we have this expression. Now just differentiate it with respect to e to the power minus lambda. Okay, if you differentiate both the side with respect to e to the power minus lambda, then you will get a series of this form, and that will be equals to this quantity. Okay, you just find out this will be equal to this quantity after differentiating. So this equality is holding from this argument. Now this will be equal to e to the power minus lambda divided by 1 minus e to the power minus lambda. So this is basically the expectation of the x. Okay, is there any doubt in this question? We have just found out first of all that which kind of random variable this gx is, and what is the density of it, which is basically what is the PMF of it, which is of the form uh, which is of the form here we have defined it, that it is this is the PMF basically, and then we have find out the expectation of Gx here. So this is basically the question was asking. So it is very important to find out the range of Gx, that what the range Gx is having and what the density it is having. So then we can find out all the expectations and movements of the random variable. Okay, we will move forward for the next question. So now suppose x is a random variable whose PDF is this: x to the power l minus 1, 1 minus x to the power m minus 1 divided by BLM. Here this b is the beta function. So BLM is nothing but a beta function, which is gamma L gamma m divided by gamma L plus m. But in this problem we do not need, we will just put BLM directly. Now what it is asking, that what is the PDF of y, that is equals to x upon 1 minus x. So if y is x upon 1 minus x, so basically what we have, Gx, y is equals to Gx is equals to x upon 1 minus x. Now, first of all, let us consider that which kind of function is it, whether it is increasing, decreasing, or it can be both. So in order to find out, now let us consider TDX of Gx, which is 1 minus x minus 1 into x divided by 1 minus x whole square. So it will be 1 upon 1 minus x whole square. So it will always be positive. So it is, since it is positive, which implies that g is strictly increasing function. Now since g is strictly increasing, we can apply directly the theorem. Now for that, let us first consider the inverse image. So we have Gx to be x upon 1 minus x. So inverse image, in order to find out the inverse image, we just equate it to y, and x is equals to y minus yx, and x is equals to will be, so it will come here, so it will be 1 plus y, so it will be y upon 1 plus y. So this is basically G inverse of y. Now in order to like compute the density from that formula, we need to have the derivative dy of G inverse y, which is derivative of this quantity, so which will be denominator as such, the derivative of the numerator minus numerator, derivative of the denominator divided by the denominator square. So it will be 1 upon 1 plus y whole square. Okay. Now we need to find out the density of y. So let us consider that density to be h. So h y y, so it will be nothing but the density of x at G inverse y into the derivative of G inverse y. Okay, so now what is the density here? The density is this. Now in place of x, just we will put the G inverse y, but the important thing is that what will be the range. So here x is between 0 and 1. So let me write it there. So what is the density here? X to the power L minus 1. So basically G inverse y, which is y upon 1 plus y. 1 plus y to the power L minus 1. 1 minus y upon 1 plus y to the power m minus 1. So here L minus 1, m minus 1 divided by b and m. Okay, into the derivative of this quantity, which is what we have found out, 1 upon 1 plus y whole square. Now here what we should have, that G inverse y should be 0 and between 0 and 1. So here G inverse y, which is nothing but y upon 1 plus y, should be greater than 0 and less than 1. Okay, so what this is giving us, so h y is equals to, if I do the calculation, it will be like this only. This should be L minus 1, and here it will be 1 upon 1 plus y to the power m minus 1 divided by this BLM and 1 plus y whole square. This BLM 1 plus y whole square. And what we are having that y upon 1 plus y. So if I consider here y, this since x is between 0 and 1 and x is between 0 and 1, so this quantity will be positive. So there is no doubt that y will always be positive. So it will be greater than 0, of course. But what will be the another inequality? So y will be greater than 0. So it will come from the left hand side inequality. So since 0 is less than y upon 1 plus y, so which will imply that y is greater than 0. But y upon 1 plus y is also less than 1. So y is less than 1 plus y. So if I take it here, then it will be, so it will be y minus y less than 1. So it is 0 less than 1. So this is again holding for all. So we can say that it will hold for, so this quantity, it will hold for every y greater than 0. So I hope this is clear, that it will hold for every y greater than 0, because from the first and condition, from this condition, we are getting that y is greater than 0, and from the second condition, there is no condition on y. Since y is positive and here it is y, so this is positive, so obviously this quantity will always be, so y will always be less than 1 plus y, so this will always hold for every y greater than 0. So this density will be of this form and it will be 0 elsewhere. So this is basically the density. Okay, is there any doubt in this?
No, ma'am. Ma'am, but for values y, can we solve it like this, that y is equal to 1 minus y is equal to x by 1 minus x, right? So if we put x is equal to
Yeah,
0,
yeah,
then
yeah. Yeah, you
it
can
will
find
be,
out like that also, but that is the same thing only, because what you are saying that y is x upon 1 minus x, then you are saying that x upon 1 minus x, and here what you have the condition that x should be between 0 and 1.
yes,
Then from there also you can find out that x is between 0 and 1, then where the what is the range of x upon 1 minus x.
yeah, sure, okay.
Okay, that way also you can find out, but that way there may be confusion, because x is between 0 and 1, 1 minus x, then you need to find out that where the method is correct, no problem, but there may be some error if you proceed from there. But in this case, you have two conditions, you just need to check out that for which y these conditions is holding. Okay.
Sure, thank you.
So this is the next question. So probability that a patient recovers from a blood cancer is 0.2. And if 200 people are known to have contracted this disease, what is the probability that let less than 45 survive? Use the normal approximation to the binomial. So basically, if I consider that the patient recovers from the blood cancer is 0.2, so I can consider that x is number of patients recovered. Okay, so I can consider that x follows the binomial distribution. Okay, where n is 200 and the p is 0.2. So x can be binomial distribution with 200 size 200 and probability 0.2. That probability that probability of the recovery. Now, what is the probability that x is? Probability that less than 45 survive means, so less than 45 are recovered basically. So probability that number of patients which are recovered is less than 45. We need to calculate this thing. Now we can calculate it using the binomial, this binomial by using the density, the PMF of binomial distribution, or we can say the CDF of binomial distribution. That is fine, but that can be needing a long calculation. We can also use it because we have already studied that there is a normal approximation to binomial distribution. So we can use the normal approximation. So for that, what we will see that here we will consider the NP term, because there we have considered the mean to be NP. So NP is equals to 200 into 0.2. So it will be 40. It will be 40. Yeah. And what we must have NPQ. So it will be 200 into 0.2 into Q, that is 0.8. So it will be 32. 8 to 16, 32. Okay. So what we will do, we will convert this X, we convert this X into standard normal. So it will be X minus NP divided by under root NEQ. So it is less than 45 minus 40 divided by under root of 32. Okay, this we need to find out. And this is a standard normal random variable. So this is basically probability Z less than, just calculate this quantity, what is it coming? 5 by root 32. Just let me know that what is it coming? 5 by root 32. So this is probability Z less than what is it coming? 5 by root 32. Just let me know.
Zero point 8838.
Okay, so it is 0.8838. Is that okay? Okay,
Yes,
so you know here that Z is basically, Z is following the normal, standard normal 0, 1. We are considering that. Okay. Now Z is following the standard normal distribution. We need to find out the probability Z is less than 0.8838. So this is basically what we have already, this notation you must have been familiar of. This is capital phi of 0.38838. So this we can calculate using the normal table. So you people have used normal table, standard normal table?
Yes, ma'am.
So you have used it?
Yes, ma'am.
So yeah, so I have this. I have just included it here. So 0.8838. Uh, so how we are seeing this table? So this is this is the basically standard normal distribution, and you need, or whenever you are seeing this table, then in that table you should like see that what the expression that phi x is mean, the meaning of phi x, because somewhere it is minus infinity to x, and somewhere it can be in another way also. So you need to see that what the expression, that what the values are there, what are the values. So it is basically calculating the integral from minus infinity to x, where x is varying here like this. So what we have 0.88. So we have this 0.8, and in the on the here what we have the 0.08 here, this one, this and this one. So what will be the intersecting value? So it will be 0.8106. So So 0.8106. So this will be the answer. So this is the way by which you can see the standard normal table, and you should see that what the expression giving. So they are giving that it is from minus infinity to x, and we are calculating the same thing. But if there is like probability z greater than 2, then in that case we must reduce our expression in this format, and then we will find out the value. So it will be 1 minus probability z less than is equals to 2. Okay, and you also notice that in that table only positive value of x are given. So what about the negative values? Like if I have probability z less than minus 0.8. Now in that scenario, what I will do? In this scenario, because there is no negative values of x are given, so in that case what we will do, since we have this normal distribution and here this is 0.8 minus 0.8, and we need to, by this expression we need to calculate this area. Okay, and this area, because of the symmetricity, this area is equals to this area, so this is nothing but probability z greater than 0.8. Now again, since the expression is given for the less than quantity from minus infinity to n, so we'll again convert it 1 minus probability z less than is equals to 0.8. Then we will write the value of this quantity from the table, and we'll find out the final value. So if there are negative quantities and if there are inequalities like this, then in those scenarios we'll convert it our expression in this format, in which the probability is given in there. So there are tables also where the probability like x to infinity are given. Okay, there are tables like that also. In that scenario, you should see that which kind of table is given. Okay, so this is basically about the how you should see the normal table. So the things which I am like highlighting, you people are getting now what I'm saying.
Yes, ma'am.
Okay. Okay, so we will move forward for the next question. So if I have a normally distributed random variable with mean 0 and variance 4. So basically I have this x whose mean is 0 and variance is 4 basically. So we have sigma square to be 4 and mu to be 0. Now, what is the distribution of y is equals to x plus b? Since we have already seen in the lecture by moment generating function formula, or we can say the proof, that the distribution of a linear transformation is again this is normal with a mu plus b mean and a square sigma square to be the variance. Okay, so y will be normal with the mean this and variance this. So this is basically normal with the mean is, since mu is 0, so it is b comma, this is a square and sigma square is 4, so it is 4 a square. Now if I say that what is the standard, so main thing is here because we've already just proved it. So main thing is what is the standard deviation for this? If I question that what is the standard deviation for this, so what will be your answer? What will be the standard deviation? Sigma will be what? So this is basically 4a square is sigma square, basically the variance. So what will be the sigma? What will be the sigma?
2a.
2a.
Of the y distribution, correct?
What?
Of the distribution of y, हम उसी की बात कर रहे हैं.
Yes, sir.
We're talking about
Yes,
sigma
yes.
of y.
Yes, we are talking about the variance, or we can say the standard deviation of y. So the main point here is what I'm just focusing on, that sigma is 2a because we are just taking the square root of here and we are saying that 2a is it. But in the question you can observe that this a is not equals to 0. So a can be positive, a can be negative. Okay, so in the question it is not highlighted that whether A is positive or not. Now, if I am saying that sigma is 2A, now if A is negative, then in that case, what will be the sigma? So it is negative, but sigma cannot be negative. So in order to avoid that scenario, we will say that this sigma is 2 into mod A. Is that understood? What I'm saying, what I'm highlighting is, are you getting?
Yes, ma'am.
So we cannot like say that this is sigma is 2a just by taking the square root. We should ensure that our sigma is positive. Okay, so because this in the question it is not nowhere given that a is positive, so you should apply this mod here with a. Okay, so sigma will be 2 mod a. So this was the main point of focus for this question. Okay, so we'll move forward for the next one. So like I have a parameter z xi in a quadratic equation, this one, which is normally distributed. So basically this xi is normally distributed with the mean 0.2 and standard deviation 1. Now because standard deviation is 1 means the sigma square is also 1. Okay, variance is also 1. Now then what is the probability that the roots of the quadratic equation are real? So in order to have real roots, so we have this quadratic equation x square minus 2 xi x plus 1 is equals to 0. Now in order to have this, the roots real, so roots are real if b square minus 4ac, which is basically minus 2 xi whole square minus 4, a is 1, c is 1 here, they should be greater than 0 for the root to be real. Okay, because it comes in the root quantity, so it should be positive in order to have root real. So it is basically 4 xi square minus 4 should be greater than 0, which implies xi square should be greater than 1. Okay, in order to have real roots, xi square should be greater than 1. Now it is asking that what is the probability that the roots of the quadratic equation are real. So we need to find out the probability xi square greater than 1. Okay, now xi is a normally distributed. So probability xi square, what was inequality, greater than 1. So which is nothing but so which is nothing but probability xi, the square is greater than 1, so xi should be where the xi should lie. So it should be for the xi square to be greater than 1, the xi should be greater than 1 or less than minus 1.
Oh, sorry,
Okay.
greater than minus 1 or less than?
Greater than minus 1 and
Less than minus 1. Okay. Less than.
okay, wait a minute. I have done some mistake here. Okay, yeah, so it should be greater than 1. Okay, and
Less than
comma
minus 1.
xi should be less than minus 1. Okay, because then only the greater quantity will come. Now this calculating this is little it is a little, it can contain some error. So what we'll consider it to be 1 minus probability xi square less than is equals to 1. Okay, so in that case what we will have, the probability xi square is less than 1 means it is between xi is between minus 1 and now this is a little like we can tackle this easily as compared to this case. We can tackle this also, there is no problem, but this is easily representable and easily we can like visualize this thing. So this is probability xi between minus 1 and 1. Now what it is, now as in the question given that xi is a normally distributed with mean 0.2 and standard deviation 1. So it is not a standard normal. So we need to convert it. So what it is, probability we can write it as 1 minus 0.2 less than is equals to xi minus 0.2 less than is equals to 1 minus 0.2. Basically we are subtracting the mean from everywhere. Okay. Now since the standard deviation is 1, so we can divide it by 1 by simply, so it will be the same inequality. So this is 1 minus probability. We have converted this in a standard normal. random variable, so this we will represent it by z, and here it is 0.8 and here it is minus 1.2. Okay, now in order to find out this, so it will be nothing but phi of 0.8 minus, so it will be probability z less than is equals to 0.8 minus probability z less than is equals to 1 minus 1.2. So I can write it in the form of phi also. So this is phi of minus 1.2. So I was talking about this scenario, like if you have this negative quantity and you have a table for only positive quantities, then how will you be finding out this one? So we'll first see this to be 1 minus phi of 0.8 plus phi of minus 1.2. Now phi of 0.8 we can directly find out. We will be finding out from the table. Now let us look for this phi of minus 1.2. So this is nothing but because so this is a normal graph and you have minus 1.2 here and you need to find out this area. So this area is nothing but, due to the symmetricity, is nothing but the area which is this one. So this is nothing but probability x greater than equals to 1.2. Okay, so this is nothing but 1 minus probability x less than 1.2. So which is nothing but 1 minus phi of 1.2. Okay, so what this quantity then will become? So what is the left hand side? Probability is I square. Okay, so it is 1 minus phi of 0.8 plus 1 minus phi of 1.2. So it is 2 minus phi of 0.8 minus phi of 1.2. So phi of 0.8 is what? Phi of 0.8. So it is nothing but 0.7781. So this is nothing but this quantity 0.7781. So it is 0.7781 minus phi of 1.2. Phi of 1.2 is where? So here this is 1.2, 0.8849. So it is this quantity, 0.8849. This is 0.8849. Now you can subtract this and you can find out the probability xi square greater than 1. This is, what is it coming? Just subtract it.
0.337.
0.327.
337.
337. Okay. So this is the way by which we just use the standard normal table in order to find out the probabilities. Okay. So this we are done with this. Now next question. So probability. So the IQ level of a group of students is assumed to be normally distributed. So whatever X is representing the IQ level. IQ level of a group of students. Now with mean is 110. So mu is what we have 110 and standard deviation. So sigma is 10 here. Yeah.
Sorry to interrupt. Actually, in the previous question, can we write the probability of xi less than -1 and xi greater than 1 as probability of xi less than 1 plus probability of xi greater than 1? Because both are disjoint events.
Yeah. Just I have written it in this way. Now, if you need to calculate it further, then you need to calculate it that way only. Xi less than -1 plus probability that xi is greater than 1. Then you need to fix this random variable and make it to be standard normal. Here, make it standard normal and just find out the expression.
Both are disjoint events, right? That is
Yeah,
the
yeah.
reason.
Xi, because Xi is the both cannot hold.
Yep.
Both are
Okay.
disjoint, then we will calculate it by this method only. We will just add it.
This is showing a union, correct?
Yeah, yeah. We can say that union of the interval, and we are just finding out that probability when it will happen. So it is basically the union.
Sure. Thank you.
So anything else, or we are done with this?
Yes, ma'am. Thank you.
Okay. So here in this question, the IQ level of a group of students is assumed to be normally distributed. So basically, X is having the values, that is IQ level of the students. Now the mean, where mean is 110 and standard deviation sigma is 10. So it is important to see whether standard deviation is given or variance is given, because both the things are different. Now if total number of students in a group is 700, so total students are 700. Now what is the expected number of students who have IQ greater than 120? So we need to find out the expected number of students whose IQ is greater than 120. So basically, first of all, what we will do, we will find out that what is the probability that the student is having IQ greater than 120. Then we will multiply that probability to the total number of students. Then we will be finding out the what is the expected number of students. So first we will find out that what is the probability that a student has an IQ which is greater than 120. Okay, so basically what we need to find that probability X which is greater than 120. Okay, now X is a normal random variable with mean 110 and standard deviation 10. So we just convert it into standard normal. So this is basically probability X minus 110 divided by the standard deviation which is 10, which is greater than 120 minus 110 divided by 10. So it is basically probability greater than, what is the uh, IQ greater than 120. Yeah, we need to calculate this only. So it will be Z greater than, this will be 10 and this will be 10. So it is probability Z greater than 1, which is nothing but 1 minus probability Z less than is equals to 1. And now this is phi 1. So this is 1 minus phi of 1. So what is phi of 1? From the table, what we have, phi of 1. So basically X is 1 here, this thing 0.8413. So it is 1 minus 0.8413. What is it coming? Just calculate it. So it is 0. How much?
0.1587.
1587. Now this is basically the probability that a student is having IQ which is greater than 120. Now we need to find out what is the expected number of students which will have this probability, which will have IQ greater than 120. So expected number of students will be, because this is the probability, so this is 1587 into what is the total number, that is 700. So we will just multiply the total number. So out of 700, this is the probability. So we will just multiply it to find out the total number of students which will have this IQ greater than 120. So which is equals to 87 into 700. So it is approximately 111. So there are approximately, out of 700, there are approximately 111 students which will have IQ greater than 120. So we'll move forward. If there is any doubt, then you can ask for this question. So okay, we'll move forward. So the next question is, the diameter of a dot produced by a printer is normally distributed. So basically X is a normal random variable. What values it is taking? It is taking diameter of a dot. Okay, it is normally distributed. So it is normally distributed with mean of the diameter is 0.006 and the standard deviation. So sigma is equals to 0.001. Now, what is the probability? The diameter is between 0.005 and 0.007. So what is the probability? We need to calculate that the diameter is between 0.005 and 0.007. So it is 0.007. Now we just make it into a standard normal random variable. So it will be 0.005 minus the mean 0.006 divided by the standard deviation. We need to divide it by standard deviation, not the variance. Just keep that thing in mind. Which is less than z, it will make a standard normal random variable, which is less than 0.007 minus 0.006 divided by 0.001. So it will be nothing but 1 here, minus 1 here, and 1 here. So this is equals to probability minus 1 less than z less than 1. Now this is nothing but phi of 1 minus phi of minus 1. So this is phi of 1. Now since this is negative, so we will just manage it to be positive. So it is, so here we have this minus 1 here in this point. So we need to calculate this quantity. So this quantity is nothing but this equal to this quantity. Phi of minus 1. This quantity is nothing but this quantity. So it is, this quantity is what? 1 minus phi of 1. So this is 1 minus phi of 1. So this is twice phi of 1 minus 1. So what is phi of 1 from the normal table? So phi of 1, 0.8413. So it will be twice of 0.8413 minus 1. Just calculate it. What is it coming?
0.6826.
0.6826. Yeah. So we'll move forward for the next question. So suppose x follows normal distribution with mean 0 and standard deviation 2. So what we have with that x follows the normal distribution with mean 0 and standard deviation to be 2. Okay. Now we need to find out that what is the value, what is the distribution of y is equals to e to the power x. So we have already seen that this is nothing, this is log normal distribution. Okay. So this is log normal distribution. Actually, what is the distribution of this is the question. Then what is the expected value of y and variance of y? So we'll find out these quantities. Okay. So so this is a log normal distribution. We have already find out the density of this as a expression. So we'll just go towards the log normal distribution. So the log normal distribution was, yeah. So this was a log normal distribution. X is equals to e to the power y, where y is a normal random variable. So this was the density, and these were the expectation of x and variance of x. So we'll just put the values of mu and sigma square here to find out the expectation. So expectation of x is e to the power mu plus sigma square by 2. So it is e to the power mu plus sigma square by 2. So what we'll have? We'll have just mu to be 0 and sigma square is 4 basically. So sigma square is 4 here, so it will get cancelled. So it will be e square. And variance of x, so what was the expression for the variance? E to the power 2 mu plus sigma square, e to the power sigma square minus 1 e to the power 2 mu plus sigma square e to the power sigma square minus 1. So just put the mu value here. So e to the power sigma square, that is 4, and e to the power 4 minus 1. So this will be the variance. So these are the expected value and the variance, the value of the random variable x. So sorry, this is actually in the question, it is this is expected value of y basically, because y is e to the power x, so it is expected value of y and variance of y. So these are expected value and the variance of y, which we are just calculating directly from the formula which we have already developed in week 5 lectures. So this is regarding that. Now for the next question, assume that the maximum price of a commodity on a given day has a normal distribution with mean mu and variance sigma square. Now x is maximum price on a given day. Now if a day is given, then on a given day what is the maximum price of a commodity? So x is counting that. Now with mean mu and variance sigma square. So x is following normal distribution with mean mu and variance sigma square. So what is the shortest interval that has probability 0.99 of including the maximum price for this commodity? So what is the what is the shortest interval which will have this probability for x to be a maximum price on a given day? Now since x can be anything and its mean mu can be anything. Now this is basically mu and maybe 0 is here. Now we do not know where this mu is from 0. It can be positive, it can be negative, anywhere it can be. So we'll just consider this x, the quantity x minus mu. So x minus mu will come here at 0. So we'll consider, so the interval will be x minus mu. Let us consider that interval to be, it is between minus a and a. So x minus mu to be between minus a and a, where a is some positive constant. So let x minus mu to be between minus a and a, and we need to calculate that the probability of this, we need to calculate the value of a for which this probability is 0.99 basically. Okay, so now this x minus mu is greater than a, minus a and less than a. So x minus mu is again not a standard normal random variable. So we'll just convert it to the standard normal random variable. So it will be probability minus a by sigma less than x minus mu by sigma less than a by sigma. So it will be 0.99. Now what it is? So it is probability minus a by sigma z less than a by sigma is equals to 0.999, which is nothing but phi of a by sigma minus phi of minus a by sigma. So it will be nothing but twice of phi of a by sigma, as we have already done these things. So it will be twice of phi of a minus sigma minus 1, a by sigma minus 1 is equals to 0.99. So it is twice of phi of a by sigma is equals to 1.99, and phi of a by sigma will be 0.995. Okay, now here what you will understand, that the reverse thing we need to find out. We have the value of the integral, we need to find out the point basically. So we need to find out the a by sigma. So what we need to see in the table, that what is, where the value this 0.995 is coming, what is the point. So how we'll see this? So we'll see 0.995 in the table here. So here 0.995 is coming where? So 0.995. So 0.996 is there. 0.99. So 0.99464849, this quantity is here. So 0.9951 is here. So corresponding to this 0.9951, what is the point? So it is in the left hand side, it is 2.5, and here it is 0.08. So it is basically 2.58. So this way you need to look at the normal table for such kind of scenario. So it will be a by sigma is equals to 2.58 from the normal table. So A will be 2.58 into sigma. So what will be the interval then? So interval will be x between, so x basically should belong to, so it should belong to A plus mu sigma and so A plus mu and mu plus mu minus A. So it should be, and mu minus A to mu plus A, and what is A here? Mu minus 2.58 sigma to mu plus 2.58 sigma. So this should be the value of x in order to that maximum price is included, that the probability is 0.9 that the maximum price has been included. So basically 99% of observations are there in this interval. So this interval, what is it basically saying? That 99% of the values of x lies in this interval. So almost all values are there in this interval. 1% of the values may be outside this interval. So this is basically the interpretation for this. So I hope this is clear.
Then how did you take probability of minus a less than x minus mu less than a? Why we can't write x? Instead of x, you have written x minus mu.
So okay, if you want to write x here, if you want to write probability x less than something and greater than something. Now if you have this normal table and here, and you are writing x can be anywhere. Now x, let us consider x is here. Now if you write this to be minus a here and plus a here, you want to write it to be x minus a and plus a here. Okay, now this interval, what the question is asking, that what is the shortest interval that has the probability 0.99. Now that shortest interval can be here only because it should consider the maximum of the values. So it should be around mu only. It cannot be there because see, so if you consider this part, if you consider this part of the interval, then the values cannot be, now these values which you are considering, that these values cannot be the maximum values in this
Yes,
interval.
ma'am.
If you are
Understood, ma'am.
yeah, if you are considering here the length of the interval to be like 2a, then the values which you are getting, that cannot be maximum. That will be maximum if you consider it around the center, or you can say around the mean. Okay. Is that clear?
Yes, ma'am.
Okay. So yeah, so this is also the thing, that why we are considering it to be around the mean only, because of the question that this should be the shortest interval and it should consider the maximum of the values. So this is question 10. Now next question we are considering here, that x be a random variable whose density is like this. So this density is basically, it is nothing but it is a standard normal distribution we are considering here. By density, you can like see that 1 upon root pi to the power minus x square by 2, where x is between minus infinity and infinity. Now what the question is asking, that what will be the PDF of y is equals to x to the power 2m, where m is a positive integer. So basically what we are considering, the positive powers of x. So if the function is like this, then what will be the PDF for this? Now if I consider y to be, so basically I have gx, y is equals to gx to be x to the power 2m. So let us first consider whether this function is increasing, decreasing, or what kind of function is it. So ddx of gx is equals to 2m x to the power 2m minus 1. So basically it is 2m x to the power 2m divided by x. So this x to the power 2m will always be positive because 2m is even, and 2m will always be positive because m is a positive integer. So basically the positivity or negativity of this derivative depends upon x. So it will be greater than 0 if x is greater than 0, and it will be less than 0 if x is less than 0. So basically what is it saying? That this function gx is greater than 0 if x is greater than 0 and less than 0 if x is less than 0. So basically, which implies not gx, it is g dash x, which implies that g is strictly increasing for x greater than 0 and g is strictly decreasing for x less than 0. So what we can do, we can just apply the theorem second, which we have considered. This function will be of this form. So it is decreasing for the less than values, minus infinity to 0, and from 0 to infinity it will be increasing. So we'll apply that theorem. So for that, first of all, we'll find out the values. So we'll find out first the inverse image. So g of x is x to the power 2m. So in order to find out the inverse image, we'll equate it to y. So x to the power 2m is equals to y, implies x is equals to y to the power 1 by 2m, and here it will come plus and minus, because we are just considering now if m is 1, so we are considering basically the square root. So it can have the inverse image which can be positive and which can be negative. So we'll consider g1 inverse y to be y to the power 1 by 2m, and g2 inverse y. So we have basically two inverse images, so which is y to the power minus y to the power 1 by 2m. Okay. Because since we are taking the power 1 by 2m, now if I square this quantity, then positive negative will not make effect. I will get the x to the power 2m here. So that's why the inverse images are coming to be 2 here. Now these are the inverse images. Now what further we need to find out the derivative of these. So d dy of g1 inverse y is equals to, what is g1 inverse y? Y to the power 1 by 2m. So 1 by 2m y to the power 1 by 2m minus 1. So this will be the derivative, and d dy of g2 inverse y. So it will be minus 1 by 2m y to the power 1 by 2m minus 1. So these are the derivative. Now further what we need to consider, we have find out already all the things. Now what we need to find out the density of y. So let us consider that to be h y y. So this is equals to, so we'll sum both of them. So fx of g1 inverse y into the derivative of g1 inverse y, absolute value of this thing, plus fx of g2 inverse y and d dy of g2 inverse y. And in order for x to be for this density to be positive, where x should lie from minus infinity to plus infinity. What it implies, that g1 inverse y should be from minus infinity to infinity, and g2 inverse y should be from minus infinity to plus infinity. Okay, so that will be holding. Now for that, what we need y to be positive only, because what we are doing when we are finding out the g1, so let us consider this further. So g1 inverse y is basically y to the power 1 by 2m. So it is h y y, that is equals to, so fx of g1 inverse y. So we'll just put that value in this density, g1 inverse y value in this density, this one, in place of x. So what is g1 inverse y? We have y to the power 1 by 2m. So this is 1 upon under root 2 pi e to the power minus y to the power 1 by 2m square divided by 2. And what we have this derivative part here. So derivative is 1 by 2m, and here we have y to the power 1 by 2m minus 1. And since we are taking the mod, so second quantity will also be same, so it will be twice of this one. So this will be twice of this thing, so this will be the density. And and also what we are seeing here y is basically x to the power 2m. Now x is varying over minus infinity to infinity here. Now if we will put that value here, then this function y will also, this y will always be positive because we are taking the even power. So the range of y will be, so y will be greater than equals to 0 and 0 elsewhere. So this will be the density. So if I like further, if I simplify it, so it will be, so this 2 and this 2 will get cancelled. This 2 and this 2 will get cancelled. So it will be 1 upon m under root 2 pi to e to the power minus, and this is the square of this thing. So this 2 and this 2 will get cancelled. So it will be y to the minus y to the power 1 by m divided by 2. And this is y to the power 1 by 2m minus 1. So when y is greater than equals to 0 and 0 elsewhere. So this will be the density for the y. So we are now here we have considered all the even powers of x. So when m is 1, 2, 3, 4, we will get this x square, x to the power 4, x to the power 6, x to the power 8 kind of functions. And varying the value of m, we can then find out the density of the y. Here also we can vary the value of m and find out the density of y. So I hope this is also clear to you. We have only just used the second theorem which we have defined in the recap session. So I'll move forward for the next question. So what we have, that we have a random variable which is a basically binomial random variable whose probability mass function is given as probability x is equals to r NCR p to the power r 1 minus p to the power n minus r. Now here the range of x is varying from 0 to n, and p is between 0 to 1. Now what we need to find out, we need to find out the PMF of ax plus b. Now the main thing which you need to focus out is that where this y is basically lying. So if x is lying for the first part, if x is lying, x can be 0, 1, 2 up to n. Then y is equals to ax plus b. So what will be the range of this thing will be? So when x is 0, it will be b. When x is 1, it will be a plus b. And when x is 2, so it will be 2a plus b. And up to so on, then it will be na plus b. So the range of y is like that. So y is varying basically over this set. Okay, so we have found out the range of y. Now we'll find out the PMF. So probability y is equals to y, we need to find out. So this is nothing but probability y is ax plus b. So ax plus b is equals to y. Okay, so which is probability ax plus b is equals to y. So we'll shift the b and a there. So it will be probability x is equals to y minus b by a. Okay, important thing here is that y can be what? It is of the form ak plus b. So y is equals to ak plus b, where k can be 0, 1, 2 up to n. Okay, so this is the thing that y, the range of y should be mentioned here. So this is probability x is equals to y minus b by a. So what is the PMF of this is NCR. So it will be NC y minus b by a p to the power r, that is y minus b by a, and 1 minus p to the power n minus r, that is y minus b by a, and the range of y is this thing. So this will be the basically the PMF of y is equals to ax plus b. So mentioning this range is important, that where this y is varying. So basically probability y is equals to y is equals to ncy minus b by a, p to the power y minus b by a, 1 minus p to the power n minus y minus b by a, where y is of the form ak plus b, k is 0, 1, 2, n. So this is the PMF. Now for the second part, we have y is equals to x square. So we need to find out the probability y is equals to y, and y is what? Probability x square is equals to y. So probability x is square is equals to y. What it means that x can be probability x can be minus of under root y plus probability x can be under root of y. Now x is a binomial random variable and it cannot take negative values, so this probability will be 0. So it is basically 0 plus probability x is equals to under root y. Now this will hold only when y is a perfect square, because if y is not a perfect square, then x will be an irrational number, and binomial random variable does not vary over the irrational number. So what we need to write, that y is of the form y can be 0, it can be 1 square, which will be 1, 2 square, 3 square, and dash 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 n square. So this will be the range of this. So this is probability y is equals to y is equals to, so probability x is under root y, so it is nc under root y, p to the power under root y, and 1 minus p to the power n minus under root y, where y is ranging over 0, 1, 4, 9 to n square. So this is important. Writing this is important, because if y is not here, then the probability will be 0 otherwise. Because if for suppose let y is 3, then in that case probability this is under root 3, and for that case this binomial distribution is not defined. So that's why this should be a perfect square. It will be 0 otherwise. Now the next one is y probability, this distribution of under root x. If I consider probability y is equals to y, where y is what? Probability of under root x is equals to y. Now probability under root x is equals to y means probability x is equals to y square. Okay. Now probability x is equals to y square. Now y should be such that its square is an integer. So basically y is running over. So it is 0, 1, under root 2. So basically it is plus minus 1 plus minus under root 2 plus minus under root 3 dash dash plus minus under root n. This kind of values y is taking. So it will be probability x is equals to y square. So it will be what? It will be ncy square p to the power y square 1 minus p to the power n minus y square, where y can be plus minus under root k, where k is ranging over 0, 1, 2, n, and it will be 0 elsewhere. So this is basically the format for the PMF for y when this y is under root x. So I hope these questions are clear. If any one of you have any question, then I can discuss that. And if there is no question, then I'll just discuss one more question. So there is no question. So if there is no question, then I'll just discuss one more question.
Sure.
So my screen is visible to you all?
Yes, ma'am.
Okay. So I'll discuss one more question then. So if x is a positive random variable of continuous type, so if we can see from here that x is a uniform random variable, basically varying over the interval 0 to 1, and the density is 1 from 0 to 1 and it is 0 elsewhere. Now we need to find out the PDF for the random variable, that is x upon 1 plus x. So we need to first, so we have u that is equals to, so we have u that is equals to gx, we can consider that to be x upon 1 plus x. Now we just find out that whether this function is increasing or not. So we'll consider g dash x, which is denominator as such, minus numerator divided by 1 plus x whole square. So it will be 1 upon 1 plus x whole square. So the derivative will be this. Now this will always be positive, obviously. So this implies what? That g is strictly increasing. Now we can apply the theorem because g is strictly increasing. Now in order to further proceed, we have to find out the inverse image. So we have gx is equals to x upon 1 plus x. So which will equate to 2y. So it will be y plus yx. So x will be nothing but y upon 1 minus y. Okay, so this is basically g inverse y. We need to find out the value of derivative of g inverse y. So d dy of g inverse y. So it will be 1 minus y minus minus of y divided by 1 minus y whole square. So it will be 1 upon 1 minus y whole square. So this is the derivative. Now we'll apply the theorem. So what is the theorem? Let us consider the density of this. In place of y, since we have that capital U in the question, so just it is notational. There is no difference. We'll just use U here. Okay. Because of the notation in the question, you can also use y. It is just the representation. Ox is, this was equals to u, so it is u plus ux. So x is u upon 1 minus u, so it is g inverse of u. And here what we have, g inverse of u, so it will be the derivative of this one, so it will be 1 minus u minus minus of u divided by 1 minus u whole square. So it will be 1 upon 1 minus u whole square. So it is a derivative. Now we will apply the theorem. So let us consider the density of u to be h u. So that will be f of x g inverse of u into derivative of g inverse of u mod. Now, in order to find out this density this to be positive, this g inverse u should lie between 0 and 1, and it will be 0 elsewhere. Okay. Now further we will find out what is, so fx of g inverse u. So fx of something, giving to find out, it will be 1 when g inverse u lie between 0 and 1. So this will be 1, this quantity. What is the derivative? So derivative is 1 upon 1 minus u whole square. So it is 1 upon 1 minus u whole square. Now g inverse u is what? So g inverse u is u upon 1 minus u. So where 0 less than u upon 1 minus u less than 1, and it is 0 elsewhere. Now we will just further calculate that u upon 1 minus u is greater than 0. Now if I consider u upon 1 minus u greater than 0, Now if I see here that u is basically x upon 1 plus x, and x is always positive, so u is always positive basically. Okay, so since u is always positive, so we can just, and u is positive, and also what we can say, also what we can say, since x is between 0 and 1, so since x is between 0 and 1, so if I consider this 1 plus x, so 1 plus x will always be greater than x, because here x cannot be negative. So 1 plus x is greater than x, which will imply that x upon 1 plus x will always be less than 1. Now this will not hold if x is negative, x is also taking negative values. But here, since x is always positive, so x upon 1 plus x is less than 1. So basically u is always less than 1. And since x is greater than 0, so u will always be greater than 0. So we can consider it directly from here, or also we can say that u upon 1 minus u is greater than 0 implies that u is greater than 0, and u upon 1 minus u is less than 1. So what we'll do, we'll just u is less than 1 minus u, and since u upon 1 minus u is less than 1, so u is less than 1 minus u, and we'll put this u in left side, so it is 2u less than 1, so u is less than 1 by 2. So we are getting two conditions, that u is greater than 0 and u is less than 1 by 2. So it will be the density of the format 1 upon 1 minus u whole square when u is greater than 0 and less than 1 by 2, and it will be 0 elsewhere. So is that okay? How we are finding out the range? Because here from directly, if you want to see the values of x, so you will say that you can directly also say that x is lying between 0 and 1, and because this function is increasing, so left hand, if x is 0, this will be 0, and x is 1, then it will be 1 by 2. So it lies between 0 and 1 by 2. U will lie between 0 and 1 by 2. But this is holding because this gx is an increasing function. So you can calculate it directly like that. But if there is different scenarios, the function is not increasing, not decreasing, if there is no such kind of condition, which we will be discussing further in the next lectures, then those cases you need to find out conditions separately for different values. So this is all for today. These are the questions which I have discussed. Now if you have any doubt regarding the questions, then you can just tell me. So there are no doubts. Everything is clear.
Yes, ma'am.
Okay, so if there are no doubts, then I will be ending this meeting. Thank you everyone for listening.
Thank you, ma'am.
Okay. Okay, thank you.